Okay, welcome back to the deep dive. Today we are wading into something that feels more relevant every single day, figuring out the complexities, the risks of artificial intelligence.
And for this deep dive, we're digging into a really key document. It's from the U.S. Department of Commerce and NIST, the National Institute of Standards and Technology.
Right, the NIST AI Risk Management Framework, the AIRMF version 1.0.
Exactly. And NIST puts this forward as a voluntary resource. It's designed to help pretty much any organization dealing with AI, developers, users, everyone in between.
To help them understand and manage the many potential risks.
Yeah, and the big goal here is fostering AI that's trustworthy and responsible in how it's developed and how it's used.
And they stress it's meant to be flexible, right?
Hmm.
Not specific to one industry, not tied to one use case, and rights preserving.
That's right. Think of it less like a strict rule book, you must do X, and more like maybe a map and a compass for navigating this AI risk landscape.
Giving you structure, guidance, helping AI systems become more trustworthy over time. Okay, so our mission today, take that map, that framework, and really focus on part one, the foundational information.
This is the groundwork. It sets everything else up, defines the key terms, explains why AI risk is so uniquely challenging,
Identifies who needs to be involved.
and outlines what makes an AI system trustworthy. We're basically going to unpack these core concepts, topic by topic, so you get a solid understanding before we even touch the how-to in part two.
All right, let's jump right in. Let's unpack this foundational section from NIST.
Sounds good.
So logically, the framework starts with the idea of risk itself. How do they define risks specifically for AI?
Okay, so at its core, the AIRMF defines risk using two main components. The probability of something happening.
Event.
Yeah, an event. And the magnitude of the consequences if it does happen.
And importantly, consequences aren't always bad news, are they?
That's a key point. AI can have positive impacts, negative ones, or, a mix.
But when we're zeroing in on the negative side,
Yeah.
the risk,
Then the framework says it's basically a function of two things. How bad could the harm be? The magnitude. And what's the likelihood of that harm actually occurring?
and the potential harm they talk about, it's incredibly broad. We're not just talking software bugs here.
Not at all. Figure 1 in the document gives examples, things like discrimination, yes, but also threats to civil liberties, impacts on the environment, even economic disruption.
It can hit individuals, groups, whole communities, right up to society and the planet.
Absolutely. And for managing that risk, the framework points to the standard ISO 31000 definition. Risk management is basically the coordinated activities an organization uses to direct and control itself when it comes to risk.
So the goal is really twofold. Minimize the bad stuff you anticipate,
Right.
but also actively look for ways to maximize the good stuff.
Exactly. It's not just avoiding harm, it's about enabling the benefits, but safely.
Which leads, hopefully, to more trustworthy AI systems.
That's the path. Doing risk management effectively gets you trustworthy AI, which lets you realize the potential upsides.
Okay, that makes sense conceptually. But here's where, for me, it gets really interesting. If managing risk is the goal, what is it about AI risk that makes it so much tougher than, say, managing risk for traditional software?
Yes. That's the critical question. Part 1 really digs into. Section 1.2, Appendix B, they highlight unique qualities of AI risk.
Like what?
Well, first, big thing. AI systems are inherently socio-technical,
Meaning?
meaning they're deeply tangled up with human behavior, societal norms, how people actually interact with them. It's not just the code.
Unlike, say, a database program, which mostly just sits there once it's built.
Exactly. With AI, the data it learns from can change, sometimes significantly, sometimes unexpectedly. And that affects how the system behaves, its trustworthiness, often in ways that are hard to predict. The systems themselves and the context they operate in, they're often incredibly complex. Makes it hard to even spot problems, let alone fix them.
And because they're socio-technical.
The risks and the benefits, too, they often emerge from that interplay between the tech stuff and the social stuff, who's using it, how, where.
Okay, so the framework breaks down these specific challenges for managing AI risk.
It does, into a few key areas. First up, risk measurement. How do you even put a number on AI risk if the potential harms aren't even clearly defined yet? It's tough.
You're trying to measure something fuzzy or constantly shifting.
Right. Or maybe the impact just doesn't fit neatly into standard metrics. Think about challenges like risks coming from third-party code or data you didn't create.
Or risks that just pop up after deployment, ones you didn't foresee.
Exactly. Emergent risks. Plus, there's just no universal agreement on reliable metrics for things like fairness or bias or privacy impact. And any metric you do choose might oversimplify or carry hidden biases or not account for different groups or contexts.
And the risk isn't static, right? It changes across the AI's lifecycle.
Absolutely. What's acceptable risk in a lab setting might be totally unacceptable out in the real world. Plus, you have the whole black box problem. The inscrutability of some complex models makes it hard to know why a risk happened.
And comparing AI to humans isn't always straightforward either.
Right, especially when AI is augmenting humans or doing tasks differently. Establishing that human baseline is tricky.
Okay, so measurement is a big hurdle. What about deciding how much risk is okay?
That leads to risk tolerance. And the framework is very clear here. It doesn't tell you what your tolerance should be.
It's up to the organization.
For the actor, yes. It's about your readiness to bear a certain level of risk to achieve your goals. And it's super contextual.
Right. Recommending movies versus driving a car.
Yeah.
Very different tolerances.
Hugely different. And it's influenced by laws, regulations, your own company culture, resources, everything. Since the framework is voluntary, organizations really need to define their own reasonable risk tolerance where rules don't already exist, building on what they already do.
Okay. Measurement's hard. Tolerance is context-specific. How do you decide where to focus your efforts? You can't fix everything.
Which brings us to risk prioritization. You simply can't eliminate all negative risk. It's impractical, wastes resources. So prioritizing is key.
And the framework suggests a good risk management culture helps with that.
Yeah, it helps you allocate resources purposefully. You prioritize based on the assessed risk level and the potential impact.
So systems interacting directly with people using sensitive data, or where failures could be really severe, those get top priority.
Precisely. And there's a crucial line drawn. If the assessed negative risk is deemed unacceptable, think imminent, severe, catastrophic harm, then development or deployment should stop, halt, until those risks are managed down.
That seems important. And they mention residual risk.
Yes, the risk that remains even after you've done your mitigation. That needs to be documented and communicated, especially to end users.
That transparency about what risk is left over.
Yeah, that feels crucial. It is. And the final challenge area is organizational integration and management. AI risks can't live in a bubble.
They need to be part of the bigger picture.
Exactly. Integrated into the organization's overall enterprise risk management, alongside cybersecurity risk, privacy risk, financial risk, whatever the organization already manages.
So it's not just a tech team problem, it's a business problem, or an organizational one.
Absolutely. And that needs clear accountability, defined roles, responsibilities across the board, needs the right culture, the right incentives, ideally driven from the top, from senior leadership.
And the framework notes this might look different for small versus large organizations.
Yeah, acknowledges that small or medium-sized businesses might face different hurdles than, say, a huge corporation.
So wrapping up this section, part one really hammers home that AI risk isn't just a technical issue. It's complex, multifaceted, with these unique socio-technical dimensions.
It absolutely sets the stage for why we need a structured approach like the one this framework offers.
Okay, that covers the why it's hard. Now, who is this framework actually for? Who are the players involved in managing this complex risk landscape?
Right, that brings us to section 2, the audience. The framework is aimed broadly at what it calls AI actors, all across the AI lifecycle.
AI actors, is that a standard term?
It adopts the definition from the OECD. Basically, any person or organization playing an active role anywhere in the AI system's life. That includes deploying or operating it too.
And it seems to really emphasize getting lots of different viewpoints involved.
Oh, crucially. The framework states pretty clearly that effective AI risk management just isn't possible without a broad set of perspectives. Diverse teams demographically, different disciplines, they're essential.
Why?
They help spot potential problems and risks that a purely technical team might completely miss. Leads to better ideas, better solutions overall.
And the framework uses some figures to illustrate this. Life cycle stages, actors.
Yeah, figure 2 lays out the typical AI life cycle. Plan and design, data collection, model building, then testing and validation, TEVV, they call it deployment, and ongoing operation and monitoring.
And it overlays dimensions like context, data, model, with people and planet at the center.
Exactly. And figure 3 maps different types of AI actors onto those stages.
So based on that, who's the primary audience? the main target users?
The primary audience is really those actors directly involved in the technical side and the application context. So the people designing, developing, deploying, evaluating, using the AI systems.
Like data scientists, developers.
Yeah, data scientists, developers, system operators, the evaluators, system integrators, even procurement folks deciding which AI tools to buy. Appendix A gives a whole list.
You mentioned TDV test, evaluation, verification, validation experts earlier.
Yes, they get a specific call-out as key players within that primary audience. They're involved throughout the life cycle, providing really critical insights. They're key for assessing risks, tracking emergent ones, evaluating against all sorts of norms, technical, societal, legal, ethical.
Okay, so that's the builders, the operators, the testers. What about the secondary audience?
The secondary audience are actors mostly in that people and planet dimension. They play a crucial role by informing the primary audience.
Who does that include?
Think groups like industry associations, standards bodies, researchers, civil society organizations, advocacy groups, and really importantly, end users and the individuals and communities potentially impacted by the AI.
What's their role in managing risk? How do they inform?
Their role is vital for bringing in that real-world context, making sure systems are developed and used responsibly. They help organizations understand the potential impacts, the actual impacts. They provide guidance on norms, help define boundaries, technical, social, legal, ethical ones.
And promoting discussion about trade-offs.
Exactly. Those tricky trade-offs between values like civil liberties, equity, the environment, economic goals. This secondary audience helps surface and discuss those.
So managing AI risk isn't something the tech team just does on their own in a corner.
Definitely not. It needs input, collaboration from this much wider group. That's a huge takeaway here. Successful AI risk management depends on collective responsibility, all these different actors working together.
That idea of collective responsibility.
Yeah.
That really sticks. Okay, so we've got the challenges, we've got the players. Let's talk about the goal. How do we know if an AI system is actually good, reliable? The framework uses the term trustworthiness.
Yes, AI risks and trustworthiness, that's section 3. And the framework basically positions trustworthiness as the outcome of doing risk management well. Trustworthy AI systems are responsive to the criteria, the values that matter to the people and communities they affect.
And it lists specific characteristics that make up trustworthiness.
It does. 7 key characteristics shown nicely in figure 4. They are valid and reliable, safe, secure and resilient, accountable and transparent, explainable and interpretable, privacy enhanced, and fair with harmful bias managed.
Looking at figure 4, valid and reliable is like the base layer, the foundation.
Exactly. If the system doesn't fundamentally work correctly for its intended purpose, none of the other stuff matters much, does it?
Makes sense. And accountable and transparent is shown vertically, touching all the others.
Right, because that visibility, transparency, and knowing who is responsible, accountability, those are fundamental to assessing and managing all the other characteristics and their associated risks.
Now, these sound like technical things, but the framework calls them socio-technical attributes.
That's a critical point. These aren't just about the code. They're shaped by social factors, organizational behavior, the data you use, the model choices you make, and critically, how humans interact with and oversee the system.
So human judgment is still essential.
Absolutely. The framework explicitly says human judgment is needed just to define the right metrics and thresholds for these characteristics in a given context.
But are these characteristics always easy to achieve together? What if making a system more interpretable makes it slightly less accurate? Or more private makes it harder to check for bias?
You've hit on a key challenge the framework acknowledges head-on: trade-offs. You often can't maximize all these characteristics simultaneously. Addressing them one by one isn't enough.
So, for example?
Well, like you said, interpretability might come at the cost of some accuracy sometimes. Enhancing privacy might limit the data you can use to ensure fairness across different groups. Security versus transparency? There are many potential conflicts.
How do you handle those trade-offs then?
The framework says it requires really careful consideration of the specific context, the specific application, and the values that are most important in that situation. And those decisions about trade-offs, they need to be made transparently with clear justification.
And bringing in those diverse perspectives helps.
Vitally. Input from subject matter experts, affected communities. That contextual awareness is crucial for understanding the risks that arise from these trade-offs, especially in social contexts.
And different actors might weigh these differently too, right? A developer versus someone deploying it.
Absolutely. A developer might focus on model reliability, while the deployer might be intensely focused on safety and fairness in their specific use case.
Which circles back to that collective responsibility idea.
Exactly. It's a joint effort across everyone involved to figure out if an AI system is appropriate for a certain use and how to use it responsibly, based on assessing trustworthiness, risks, impacts, costs, benefits, all informed by diverse viewpoints.
Okay, let's quickly touch on what the framework says about each characteristic. First, valid and reliable, the foundation.
Right. Validation is about confirming the system meets the requirements for its specific intended use. Is it doing the job it's supposed to do in context? Reliability is about consistent performance over time under the expected conditions, basically overall correctness without failing.
And what contributes to that?
Key factors include accuracy, how close the outputs are to the true values, using metrics like false positive negatives. Needs realistic test data, good documentation. And robustness or generalizability, can it maintain performance even when conditions aren't perfect, even with unexpected inputs?
The goal being.
Appropriate function across a range of conditions, and importantly, minimizing harm even if it operates unexpectedly. And assessment isn't just pre-deployment, it's ongoing monitoring, often needing human oversight.
Okay. Next, safe.
Safety here borrows from standard ISO definitions. The system shouldn't endanger human life, health, property, or the environment under defined conditions.
How do you improve safety?
Through responsible practices, design, development, deployment, clear information for deployers and users, responsible decision-making by those deployers and users, and documenting risks based on actual evidence.
And safety risks get prioritized.
Definitely. Risks potentially causing serious injury or death are the absolute highest priority. Approaches include designing for safety early, rigorous testing and simulation, real-time monitoring, and having mechanisms for shutdown, modification, or human intervention.
Learning from other fields.
Yes, taking cues from safety-critical fields like transport or healthcare and aligning with sector-specific standards where they exist.
Got it. How about secure and resilient?
Resilience is about withstanding adverse events or changes, could be attacks, could be unexpected inputs, and maintaining core functions, or at least degrading safely if it fails. Security, which resilience is sort of a part of, is about protecting confidentiality, integrity, and availability. Think cybersecurity practices.
So security is more about deliberate attacks. Resilience is broader.
Kind of. Security definitely focuses on avoiding, protecting against, responding to, and recovering from malicious attacks. Resilience covers robustness more broadly, including handling unexpected situations, maybe even adversarial use beyond just bad data.
Specific AI security worries.
Things like adversarial examples, tiny input changes that fool the model, data poisoning messing with the training data, or attacks trying to steal the model or sensitive data.
Okay. Accountable and transparent. You said they're linked.
Yes, accountability really presupposes transparency. Transparency means making information about the system and its outputs available to those interacting with it.
But meaningfully available.
Right. The right level of detail for the right person based on their role, their knowledge. Good transparency builds confidence.
What kind of info?
Could be design choices, training data details, the model itself, intended use, how it was deployed, who made key decisions. It's often crucial for people seeking redress if something goes wrong.
But transparent doesn't automatically mean good.
Exactly. A system can be transparent, but still inaccurate, insecure, unfair, or privacy invasive. But it's really hard to tell if an opaque system has those good qualities.
And accountability itself.
That's about the roles and responsibilities of the different AI actors. It varies by context, legal, cultural, sector. The framework suggests proportionality. The bigger the potential consequences, especially for life or liberty, the greater the need for proactive transparency and accountability. Risk management practices help establish this.
Balancing acts involved?
Sure, need resources, need to protect legitimate proprietary info. Things like tracing data provenance can help. Transparency tools are evolving.
Okay, next. Explainable and interpretable. You distinguished these earlier.
Right. Explainability is more about the mechanisms. How does it work internally? Interpretability is about the meaning of the output. Why did it make that decision? What does it mean for the user?
And together they build understanding and trust.
Yes. They help operators, users, everyone get a handle on the functionality, the trustworthiness, the outputs. The framework suggests that a lack of understanding often fuels perceptions of risk.
How do you manage that?
By describing the function appropriately for the user. Interpretability helps address risk by communicating the why behind a decision. NIST has other resources on this.
So transparency is what, explainability is how, interpretability is why meaning.
That's a good summary.
Then privacy enhanced.
Privacy here is about safeguarding human autonomy, dignity, identity. Freedom from intrusion, limiting observation, control over your identity. It points to the NIST privacy framework.
Guiding values.
Anonymity, confidentiality, control. Privacy risks interact with security, bias, transparency, more trade-offs. AI brings new risks, like inferring private info from aggregated data.
Technologies to help.
PT's privacy-enhancing technologies are mentioned. Data minimization techniques like de-identification, aggregation, but again, trade-offs. Using PETs or sparse data might hit accuracy, which could affect fairness assessments.
Which leads us to the last one. Fair with harmful bias managed.
Fairness, a really complex concept, involves equality, equity, and critically addressing harmful bias and discrimination. Perceptions of fairness vary hugely, culturally, contextually.
And just reducing bias isn't the whole story.
Right. The framework is careful to note. Mitigating bias doesn't automatically equal a fair system. It might still be inaccessible or affected by the digital divide or amplify systemic biases already out there.
And bias comes in different flavors.
Yes, it references NIST SP 1270, which talks about systemic bias from society, organizations, data collection, computational statistical bias from data sampling algorithms, and human cognitive bias, how we humans perceive and interact with AI. Bias can creep in unintentionally.
And AI can make it worse.
It can definitely increase the speed and scale of bias, perpetuate it, even amplify it. Fairness is tightly linked to transparency and justice in society.
Wow, that's a really comprehensive set of characteristics for trustworthy AI. Gives real substance to the goal.
It provides the key attributes that AI actors need to be thinking about and managing across the entire life cycle.
So after all this, the challenges, the actors, the trustworthiness goals, how do we know if using this framework actually works? Section 4 addresses its own effectiveness.
Yeah, the framework acknowledges that evaluating its effectiveness is an ongoing thing. It's part of future NIST activities, working with the community.
So it pushes users to assess their own use of it.
Exactly. It encourages organizations using the AIRMF to periodically check. Has this improved our ability to manage AI risks? Look at changes in policies, processes, maybe specific indicators, and the actual outcomes you're seeing. NIST aims to collaborate on developing metrics and methods for this evaluation.
What benefits does the framework expect organizations to see if they use it?
It lists quite a few potential benefits, things like better processes for governing, mapping, measuring, managing AI risks, better documentation.
Improved awareness.
Yes, improved awareness of those trade-offs we talked about, understanding socio-technical approaches better, more insight into risks. It can also lead to more explicit, thoughtful, gonna-go decisions about deploying AI.
What about inside the organization?
It should help establish clearer policies and practices for accountability around AI risk, foster a better organizational culture, one that prioritizes identifying and managing risks and impacts, and improve how information about risks, decisions, lessons learned gets shared internally and maybe even externally.
Anything else?
Yeah, users should develop better contextual knowledge, making them more aware of downstream risks. It should strengthen engagement with stakeholders and other actors, and importantly, boost their capacity for doing that rigorous testing and validation, the TEV work.
That paints a picture of the framework not as just a checklist, but as a tool for ongoing improvement.
Precisely. It's meant to be a living resource, something that evolves as we learn more about AI, and something that helps organizations mature their own practices over time.
Okay, wow. We've really unpacked part 1, the foundational information of the NIST AI RMF today. We've grappled with why AI risk is so uniquely complex,
Identified the wide range of actors needed to manage it.
and explored those key characteristics that define what a trustworthy AI system looks like, according to NIST.
And understanding these foundational concepts is just so critical because, as the framework emphasizes, these AI systems are different. They bring unique challenges that really demand this focused approach to risk and trustworthiness.
And all this groundwork we've laid today, understanding the what's and why and who, that sets us up perfectly for part 2, the core of the framework.
Right. That's where NIST gets into the practical functions: govern, map, measure, and manage. The how-to for putting these principles into action.
Those functions are like the operational blueprint for building that risk management culture part 1 describes.
Exactly.
So as you, our listener, think about everything we've discussed, the fast pace of AI development, those tricky trade-offs between trustworthiness characteristics, the need for this collective responsibility.
Hmm.
What do you think is maybe the single most critical factor for ensuring responsible AI actually happens in practice?
Hmm. That's a great question to leave people with. Thinking about it, maybe it really comes back to that continuous, meaningful engagement with diverse perspectives all the way through. That feels like the mechanism to catch blind spots and navigate those really complex socio-technical issues and trade-offs.
An excellent point to ponder. Well, thank you so much for joining us on this deep dive into the foundations of the NIST AI RMF.
It was a pleasure. We really hope this gives you a solid starting point for exploring this important document.
Definitely encourage you to find the NIST AI RMF online. Check it out for yourself. And please join us next time as we continue our deep dive.